Good morning, everyone, and welcome to today's product profile webinar, Surface Bonded Soluble Salts versus Coatings Failures. We're glad that you're joining us. My name is Josiah Lockley, and I'm with Paint Square. It is my pleasure to be the moderator for today's Paint Square Product Profile webinar. Now, before we begin, I want to take a moment to thank and acknowledge today's sponsor, Chlorid International Incorporated. Chlorid International is the world leader in soluble salt information, measuring devices, and decontamination products for surface preparation. A major cause of premature coating failures are remaining surface salts which are not detected or treated prior to coating application. The ChlorTest CSN kit accurately and easily detects the presence of residual chloride, sulfate, and nitrate salts on the surface, which are prevalent in the water and wastewater processing industry. Chlorid liquid soluble salt remover is recognized as the most effective, easiest, and economical tool for removing surface salts to meet stringent job specifications. For more information, visit www.chlor-rid.com for any information on their products, or you can contact them at 800-422-3217. Let's talk about the format for today's webinar. This webinar will be 45 minutes, followed by a 10-minute question and answer session. There you'll have the option to send us questions via the questions chat box that you should see on the right-hand side of your screen. You can send questions if you have any technical issues. You can send questions of that nature to us, and we hope to get them resolved in a timely manner. Today's presentation is being recorded and will be made available by visiting paintsquare.com/webinars. A PDF copy of the reference slides are currently available as well at paintsquare.com/webinars. All you have to do, go to the site, click on the title of today's webinar, and then click on the link that says Presentation Slides. We expect to have the recording of today's webinar up by around 5 p.m. Eastern Time today. Now it's my pleasure to introduce today's speaker, Norman Pettigrew. Norman is a Gulf Coast manager for Chlorid International, Inc. Norman has been in the coatings industry since 1968. As a NACE Level 3 inspector since 1988 and residing in the Gulf Coast region, Norman has a long-standing background in the marine, offshore, and petrochemical markets and has encountered all forms of coating failures. His current employment with Chlorid International is centered around surface preparation in regards to soluble salt testing, remediation, and surface passivation. As a NACE member and SSPC charter member, Norman is well informed on current coatings and project struggles. Now at this point, I'm going to turn the presentation over to Norm.
Good morning, ladies and gentlemen. Thank you for tuning in today. Stand by.
Okay, so go ahead and click Show My Screen. Okay, we can see your screen, so take it away, Norm.
Okay, thank you, ladies and gentlemen, and thanks for tuning in today. Let me get this thing set up so we can start right away. Okay, it's a known fact that proper surface preparation is by far the most important procedure necessary for a successful coating system. This presentation is designed to discuss the best possible practices of obtaining the very best surface preparation and to give insight of the most practical and economical procedures of fighting premature corrosion before it becomes an issue. The importance of testing before, during, and after surface preparation will also be discussed. What I will discuss today is the main sources of soluble salts contamination in detail, where to test for these contaminants, how to properly treat and remove these contaminants, and the importance of final testing in order to ensure that specifications are met in order to achieve the ultimate lifespan in your coating system. We'll get started with understanding the problem intro. Okay, I have a few photos to show you. Here's a pipe rack where you can see some major problems taking place. First of all is where the arrows are pointing. You have complete coatings delamination from the 3 o'clock to 9 o'clock positions. On the piping itself, you have corrosion at interface of piping and pipe supports. If you can see my arrow, like right around this area here on the pipe supports, and corrosion at edges of angles, like here, and rust stain from overhead corrosion, of course, and that's predominantly what you're seeing there is a lot of rust stain. And this beautiful tank that we're looking at, there's poor surface preparation resulting in corrosion at the weld seams. You have pinhole corrosion due to poor spot and sweep abrasive blasting, undercreep from damaged original coatings, and surface rusting from the shell on the handrails. As you see these handrails here with the corrosion, the rust bleed running down. All in all, it's a very poor blast operation and surface preparation, all in all, taking place. Now, if you have a tank that's containing brine or processed water, clarifier tanks, things of that nature, with a high salinic solutions in the tanks, that's where we see even more predominant corrosion taking place. Here's another example of a pipe rack type situation. This is taken at a bromine plant where salts are a major problem, and you can actually see stalactites of salts coming down. We don't see that a lot in the United States, in most places, but it does happen. Okay, applying coatings over surface salts has drastic effects. Moisture passing through the coating to the substrate where salts remain creates a perfect environment for salt-induced corrosion, followed by osmotic blistering, as you're seeing here, and then coating failure. Photo number 3 shows a near white metal blast with heavy pitting in effect. We always say, let's hurry up and paint before it turns on us. As you are aware in the industry, when you see a blasted surface like that with heavy pitting take place, if you're not coating out right away, you start to see these bottom areas of the pit starting to turn to a dark brown or blackish color. And that's actually soluble salts. And if you paint over that, even if with a stripe coat, brush in coat, or anything like that, it's going to fail within about 2 years' time because you didn't remove the salts at all. There's irrefutable evidence that surface salts, soluble salts, are the leading cause of coating failure, and best stated by 2 renowned authors, Ulick and Revy, in their excellent reference book, Corrosion and Corrosion Control, is a quote you see here on the slide. Further to this, Howard Mitschke, then with Shell Global Solutions, conducted an extensive study on the impact of salts on coating performance. He won an award from SSPC in 2002 with his paper entitled Effects of Chloride Contamination on the Performance of Tank and Vessel Linings. And he summarized the results of his findings as noted. For every 1 microgram per centimeter square increase in chloride levels, the coating life cycle performance can be reduced by 50%. Salts are defined as a material that ionizes in solution, and the water, H2O salt, is an electrolyte. There are hundreds of salts in existence, but the 3 most commonly encountered problematic salts, as you will see, and I'll talk about all day today, is chloride, sulfate, and nitrate. There are others, but they're not nearly as abundant. Here's an example of some of the other ionic salts that we deal with today: iodides, fluorides, and bromides. But all of the salts are ionic contaminants that are water-soluble inorganic compounds, and they are non-visible contaminants. Why weren't salts a problem when we use lead-based paint? We all know that how harmful red lead paint is when it's exposed to mankind, and how critical the steps are in order to encapsulate or remove these red lead coatings today. Myself, after applying thousands of gallons of red leads in mostly confined spaces within a time frame of nearly 12 years, And before OSHA stepped in to protect mankind from these extremely harmful coatings, as OSHA back in those days was still in its infancy, I had contracted an extreme case of lead poisoning that ultimately damaged my central nervous system. I still suffer from this today. Nonetheless, red leads were some of the best coatings ever made, but we didn't know until it was too late how it would affect the applicators of this very product. Lead paints reacted with soluble salts to make it insoluble, as you see on the screen. Soluble salts without the lead cause corrosion when wetted by dew or rain. Paints today do not contain lead, therefore the salts remain soluble. The transition from lead-based to polymeric-based coatings and thin film coatings makes salt soluble that much more critical. Here's some of the soluble salt sources: marine bodies, acid rain, fossil fuel. You see it there, de-icing salts, vehicular emissions, and also human sweat. A lot of people don't talk about that, but I think I'll make note of that right now, that for those that don't know, the human body contains many salts, of which sodium chloride, which is common table salt, is the major one. It makes up around 0.4% of the body's weight at a concentration pretty well equivalent to that of seawater. So a 220-pound person would contain around 400 grams, which is 14 ounces of sodium chloride, which is around about 80 teaspoons of salt in your body. Since we lose the salt whenever we sweat, it has to be replaced continuously. So imagine, you guys have seen inside tanks or on a hot deck out offshore on drilling rigs or what have you, or even in refineries, chemical plants, you're blasting, and the painter or the blaster and all that is sweating, and sweat's falling down into the substrate, and it goes down in there. And what do? We instantly take a rag with solvents in there and start wiping. Well, what you're doing is taking parts of the rag and it's getting down into the micropores of the steel, for starters, and that could cause some adhesion problems of your coating. But mostly those salts that's coming out of the sweat is getting down into the steel, and you wind up coating over it. Solvent wiping doesn't remove it, it doesn't pull it out, and all it does is help to smear it, and you have the problems later on. So when you open up a tank, for example, for an API 653 inspection, a couple years down the road, you start seeing isolated spots of failures and trying to figure out what it is. And you test and you find salts. Well, chances are it came out of the human body. So in order to resolve that, I would recommend that if you're doing an internal tank job during hot summer months, to invest a little bit in air-conditioned dehumidification units to make certain that the applicators and helpers and all that are not sweating so much in there and causing future problems in your coatings. Excuse me. Also, if you're out there on a hot deck and it's out in the atmospheric zone and everything, and they're sweating like that, you may want to put a air conditioner paint hood on or something to keep that from happening. All coatings today are permeable to moisture. If no salts are present, there's no electrolyte present, and salt-induced corrosion does not occur. When moisture passes through a coating and comes in contact with a soluble salt, the corrosion process starts. Here's an example of some of the non-visible things we talk about, as we're always talking about these salts are not visible. Well, people that see table salt, they say, well, wait a minute, I can see that, but not when it gets wet and it starts dissolving and it goes down into the micropores of the steel. When you do start seeing those effects is when the micropores of the steel become inundated with the salt contamination and the moisture, and it starts turning brown, black, or what have you on there, and you'll start seeing it that way. On this drawing here, forgive me, but the only thing I don't like is the huge boulder-looking images of dirt and grit. all in all, it is a good example of what happens with moisture permeation within the coating. Say this orange is the coating and you got your steel substrate there. If you have the moisture penetrating through the coating and there's no salts on the background, it just comes right back out, and there's no corrosion taking place. The dirt and the grit, of course, it just cannot travel through the coating because it's not hydroscopic. But once it goes in and it finds these soluble salts, then the corrosion process takes place, and it will continue because abrasive blasting will not remove it from the substrate. The corrosion cell, which we've all seen over the years in the past, is like a cell battery. And to try to explain it to you a little bit more is if you have a coating and it's applied to the steel, and say over here on the left-hand side, there's no salts, there's no contaminants whatsoever. Well, when the moisture passes through the coating, it just goes in and right back out because there's no metallic pathway, there's no salt contamination, no electrolytes or anything. And when you do have salt, say there's green dots and everything are salts in there, it forms an electrolyte, it becomes a cathode, and here's your anode here, and you have to have the electron or metallic pathway, and it just continues with the corrosion process and just keeps building up, and it'll continue to go all the way through to the steel. People ask, well, why cannot we remove soluble salts just by blasting alone, abrasive blasting alone? Well, the truth is that the electrochemical attachment of salts to the substrate are greater than the forces removed to apply them. So looking at all this, you can see where it's starting to turn blackish up in the lightly pitted areas. And I say lightly pitted areas because that's what it is compared to what we see in the oil patch. We see some heavy pits, and it's pretty dense. But when you start seeing this take place and you want to test for salts, and we'll get into that in a little bit, these spots up in here is where you actually want to test to see where you are, and as well for removing them. Now, I wanted to show you some maps, and I hope you can all see this. Okay, being able to hide the control panel so I can see everything. I have a couple of slides here on some maps where it just gives you an example of where we have problems these days with sulfates, chlorides, and nitrates. This is a map from the National Atmospheric Deposition Program, and it's updated on an annual basis. And here's one with sulfates, and was measured in kilograms per hectare. For those that don't know, a kilogram is approximately 2.2 pounds, and a hectare is 2.47 acres of surface area, which is roughly 2.5 acres. So if you can look at, say, right around Lexington, Kentucky, for example, you have about 24 kilograms per hectare of sulfates there, which is very critical. And the same thing up in the, I think that's around Cambridge or something, Ohio, 31. It's pretty bad, extremely critical. Now, when you're looking over here, say California, you don't have very much sulfate issues. However, you got to make certain that you know where the steel came from to build whatever unit you're working on. So if some steel came out from around these areas and it's highly contaminated with sulfates, and it's shipped over here to California and wrecked it over here, don't be fooled to think that you only have to deal with chloride contaminants or what have you. You always want to check the steel, if at all possible, for all three of these major contaminants. In other words, to ensure that you do have everything cleaned up precisely. Here's the nitrate ion deposition. This is all 1999. We used it because it does have some number values to it. This is your farmland area where it's pretty predominant here as well. We had several years back down in Florida, we had a major failure on a coating system that we helped to resolve the issues on, where they had checked for chloride salts only, yet to find that we had complete coatings delamination in a lot of areas on this brand new unit within a couple of years, and they didn't know why, because they checked for chlorides and didn't find anything. Later on, once we came in with the CSN kits to check and everything, we found that it was highly inundated with sulfates from the previous screen. Sulfates from the previous screen, and we found out that it came from around the New York area. The steel did, and was built down here. There is a little bit of sulfate issues here from 1999, but that's rare. Down in Florida, we don't see very much of that. And here's our chloride problems. For those of you that don't know, I work down in the Gulf of Mexico area, so I'm working this particular area here quite a bit, and it's heavily inundated with chloride salts. Of course, with the chloride salts from the Gulf of Mexico, it changes every year as well as with the Pacific and the Atlantic coast. And that depends on prevailing winds, with rains coming in from the Gulf or the Atlantic or what have you. If you have hurricanes coming through, it brings in more salt. So these numbers change on an annual basis. This is the United States EPA, Environmental Protection Agency, maps of 2014. It shows a little different aspect, and this is sulfates here, and you see a lot more sulfate concentrations over on the West Coast side. Nitrates, same thing. You got nitrates here from the EPA, and basically from the Midwest all the way east is a lot of the problems with nitrates. Farm country, and you do have some on the West Coast as well. And then again, the chloride salts, which is one of the main culprits, is basically all across the seaboards. And look at Salt Lake City, Utah. It'll give you an example of chloride salts and how detrimental they are. All right, what we're going to do now is go to where to test when you want to talk about testing, or you want to complete your testing process. This is a coating system that was removed and cleaned up to a near white metal blast, and you can see that there was a lot of pitted corrosion underneath this coating system. And if you were to test for chloride, sulfates, and nitrates, you don't really want to test up in these areas where my mouse is, but where the black arrows are, the heavier pitted areas is some of the better places where you want to test, because that's the most highly concentrated salt, no matter which type of salt you're looking for. You test in those areas, and then when you're doing a blasting operation, you'll test periodically, not as much, but you do test periodically, ensure that you do are removing the contaminants, and then you test afterwards in the same spots to make sure that you've removed those contaminants according to specification. This is a prime example of a piece of steel. You see the near white metal steel showing up on basically everything that doesn't have as much pitting in process, but where the deeper the pits are, the more concentrated the corrosion is taking place at a very rapid pace. And the deeper the pits, the darker the contaminant levels. And it's very obvious right here. And of course, where you test, you want to go and test where the harshest environment is. And that'll give you an example of what depth of corrosion you're dealing with. And of course, with weld seams, you always want to test around weld seams and within 2 to 3 inches on either side. Ladies and gentlemen, you've seen over the years where a coating system fails all the time. And you know, I always brag about paint. It's not that smart. Why do you blast something, say a tank, for example, and it looks extremely well, but it starts failing at the weld seams alone, when it's the same applicator, same blaster, same atmospheric conditions, same coating, same batch, and everything applied at the same time, and then it fails at the weld seams. If you see failure at weld seams, always go and test at those weld seams. And basically all you need to do there is check for chlorides, and I can promise you that you're going to find salts there. You're going to find the chloride salts there, and we did some investigation as to why. And the stick rods that are used for welding of the carbon steels are basically inundated with magnesium chlorides and sodium chlorides, which are salts. And I checked around with the welding societies and found out that they put those sodium and magnesium chlorides into the welding flux to be able to get the arc when they're doing the welding process. So what's happening is when they're welding all these pieces of steel together, they're actually contaminating the surface as we see it today. We knock off all the BBs and pop off all the existing flux that we can see and all that. We sandblast to get a profile, but we don't remove the sodium and magnesium chlorides that are embedded into the micropores of the steel. Hence, you have induced corrosion, in fact, and don't even know it. Okay, Chlorrid has various field test kits for measuring salts easily and accurately. And in marine environments or where de-icing salts are prevalent or there's atmospheric exposure from environmental fallout, surface testing is important to making a decision on which surface preparation steps to follow. For detailed information of our test kits, please visit our website where the instructions are there, and or call one of our sales and service professionals, and we'd be more than happy to help. Again, we're testing for chloride, sulfates, and nitrates, and these are the most encountered salts. We're going to talk now about some of the test kits that we do have here. Your standard chlor test kit with the sleeve, and we have a patented chlor extract liquid formula that is placed into the sleeve, and we adhere it to the steel and massage it in for about 2 minutes, and then test with the Kitagawa titrator tube, and it will wick up all the way to the top of this tip here. And when it does, it'll give you the amount of salts in parts per million. When you see that we have something written in parts per million as far as the test is concerned, and you see a specification that says what the limits are in micrograms per centimeter square, one would wonder, why is it that way? Why are we seeing it micrograms per centimeter square on the spec, but yet we read in parts per million? It's very simple, is that micrograms per centimeter square is a surface type formula for testing salts. It's going to tell you a given surface area in centimeters. And our product is used with the chlor extract, like I mentioned before, and that chlor extract is a liquid product, and parts per million is a liquid measurement. So with the sleeve, when we test with the sleeves and everything, the inside area of the circumference of the sleeve is basically right at 10 centimeters square. And the liquid that we use for testing is 10 milliliters of liquid, and therefore the ratio for making the adjustments is 1:1. Therefore, if you see 7 parts per million, it's the equivalent of 7 micrograms per centimeter square. 10 equals 10, etc. So it's very simple. You don't have to do any special math for that. And again, this is the chlor test kit. It's a field test kit for surface chlorides. The chlor test CSN kit measures for all 3 of the main salts that we talk about: chlorides, sulfates, and nitrates. We have the chlor test A for testing for any types of abrasive, whether it's steel and shot grit or garnet or silica sand or what have you. And also we have the chlor test C for testing for ion salts, chloride ion salts, that is, in concrete. We have the chlor test W testing chlorides for water, and the new eChlor test kit, which is an electronic version of the standard chlor test that was before mentioned. We also wanted to make certain that everyone understands that we do have some new products coming out at the first of the year. So check on our website in 2018, or talk with one of our sales staff, and we can help you with some of the new stuff that's coming out in the future. We're not ready to talk about it yet, but some exciting new things. And we're looking forward to 2018 for promoting it. And decontamination sources, doing it right. An acidic product is required to effectively remove surface salts. The heading here says it's impossible to combine a salt remover and a metal surface inhibitor. That's my mistake. You can definitely do that, but it should read that it is impossible to successfully combine a salt remover and a metal surface inhibitor. Reason for: an inhibitor will only mask salts, preventing detection. Coatings fail because salts remain.
Bear with me.
The ISO 8502-2 on scope 4, the scope section, the fourth sentence, it states that amine inhibitors can form a hydroxide barrier, not water soluble, over the substrate and prevent the water from contacting the underlying salt for its removal. NACE 6G186, page 9, states that consequently soluble salt testing is usually performed prior to inhibitor application, just so you can check for those salts accurately. NACE SP 0716 on item 4.2, it says a surface inhibitor or passivator. If a surface inhibitor or passivator is used, the test area shall be prepared before testing is performed. For example, by reblasting or wire brushing to remove the barrier layer that can mask any salts. So don't be fooled, ladies and gentlemen. You cannot take an alkaline type product and successfully remove salts. It does require a slightly acidic product to remove salts, in the Chlorrid product. ASTM 536716, basically alkaline treatments form a barrier later, preventing salt detection and removal. In over 90 years now, there's been the AAA factor regarding pipelines, auto industries, and steel fabricating, where they've used alkaline products and followed by an acid wash and then another alkaline product in these industries. Think about the automobile industry, they still kind of do that. And the reason for is when they're doing the cutting of the steel, they use cutting oils, machine oils, for example, and those oils get into the steel, into the substrate of the steel there, or the micropores, and we need to use an alkaline type product to wash these machine oils out. And then we'll treat with the acid product to remove any salt contaminations. And then if you need an alkaline, again, you come back with the alkaline product to preserve the steel prior to the application of the primer. And for using our products, you think about the marine environment de-icing salts that we had talked about before. And if you do find excessive salts, there's nothing in writing yet by NACE and SSPC and ISO, but they're all working on it now to come up with a standard. And as we speak, the standards are generally made by the owner of the equipment. But mostly what we're seeing in the industry is that anything for immersion, submersion, buried pipeline, tank bottoms, things of that nature, the industry is requiring about 3 micrograms per centimeter square or less for those types of conditions. The industry is allowing 5 to 7 micrograms per centimeter square or less for atmospheric zones. So if you do some testing, whether it's chloride, sulfates, or nitrates, and you find that basically these limits have not been met and you need to reduce the salt contaminants in there, you would just follow this pattern and go and use the Chlorrid product. We generally dilute it at 1 to 100, which is 1 gallon of Chlorrid to 100 gallons of clean, fresh water. Sometimes we'll dilute as much as 1 to 50 if we're in the extreme case scenarios such as offshore drilling rigs, salt mines, things like that. And it can be used in vapor abrasive blasting. Here we got surface preparation at 1 to 50. We can still do that at 1 to 100. It depends on the type of work that you're doing. You can contact us and we'll work with you to see what works best for you for what you're needing. You can use 3,000 PSI pressure washing, dilute at 1 to 100, and make sure that you cover every square inch, and you'll be able to get it clean. There's no need to rinse, and we do not recommend rinsing after use of Chlorid, because most of the waters in our industry today has about 35 to 45 parts per million of chlorides in the water itself. And so if you come back and just freshwater rinse after treatment, you just recontaminated your surface area. So just use the dilution rates that we recommend, and after it dries off, that's it, because the Chlorid treats the salts, pulls it out of the steel. It's electrochemically attached. It pulls it out of the steel, flushes it away with the water that's in there. It just flushes everything away, and now you have this clean steel to work with. We talked about tests before, during, and after Chlorid application. The reason we say during the Chlorid application is because we don't want you to test before and test after, and then all of a sudden you say, wait a minute, it hasn't met specifications. So you got to go back and redo the whole job. We don't want you to do that. What we want you to do is test, find out where your problem areas are, and then have your applicator apply the Chlorid at, say, a 25 square foot surface area. Let it dry, blow it dry, and then come back and test in those areas where you found the high concentration, and just make sure that the applicator is doing the job well enough to be able to remove everything successfully. We recommend that you keep the nozzle about 4 to 6 inches from the substrate, and that you cover every square inch just as if you were applying the coating or something. And we also recommend that if you can have one of the rotating tip turbo type nozzles, that works best, and do that. And what we find is that generally if you're still not meeting your specification after you tested the 25 square foot area, just have your applicator slow your travel speed down a little bit. Slow the travel speed down a little bit, and you'll make sure that you can get everything out. I don't want to see you have to do the job twice. So that's why we say during. Here's a comparison. We had one of our customers several years ago, actually, that used the Chlorid for treatment, but the reason he didn't use a 3,000 PSI pressure washer is because he only had a 5,000 PSI on the job site. So he went ahead and done it anyhow and magnified it, and this is the cleanliness that you see, and it works extremely well. The Chlorid is a proven soluble salt remover. It's one-time use only. It's compatible with all coatings. Why is it compatible with all coatings? Because like I said earlier, is that it's all washed away. There's no Chlorid left on the steel in any way, shape, or form. It's clean steel when it's done. And you can apply it through any high pressure equipment, even UHP blasting. It removes light surface oils that I talked about before. Light surface oils, not a whole bunch of it. And just something you'd have to test with on your own to make sure that you got it all clean. And it dilutes with potable water. We don't need high purity water or demin water. There's no concerns of scum, residue, and evaporation. Some of you with vapor blast equipment have seen in the past where the machine starts clogging up after using inhibitors, and you need to bring it in for repairs, and you need to get all the calcium built up that's inside those machines and clean it up. Well, with our products, there's no worry about that. We don't have that type of issue. We will not leave the scum in the surface. And there's no rewashing prior to coating. We have stocking points close to basically all markets and a wide distribution network. Check with us and we can get you set up with a distributor nearest you. It's economical. People want to know about the cost and everything. It's basically pennies per square foot when it's all said and done. It's very easy to handle. It's user friendly. It's environmental friendly. It's non-combustible, non-flammable, non-hazardous. and it has no volatile organic compounds. This is a 1950s vintage trailer that we did, and it was followed with chloride and used with chloride and followed with a whole blast rinse. This is 1950s, and look at the bottom of it there, how beautiful it looks today. Holding the blast, if you see that you don't have any chloride contaminants or sulfate or nitrate contaminants, and you don't need chloride, or it's already been treated and taken care of, then you want to save your blast to be able to come back in the next day or so to paint out, and you would use the whole blast. That's only when the salt specified limits have been met. Whole blast is a surface passivator. It's an alkaline type product. It does not remove salts, just minor surface salts. Yes, it'll remove surface salts in a heartbeat, but not these electrochemically attached salts that we're talking about. It would just mask over it. Chemically changes the surface to a less reactive state and eliminates surface corrosion caused by wet metal surfaces. It stops the formation of rust, and you apply it at basically 1 to 50 dilution rate with potable water, and all that's required is a 1500 psi pressure washer, and just add it to the water with vapor blast equipment or whatever, and you rinse it without the abrasive to remove particulates in the blast matter. It dilutes with potable water again. Again, no D-min or high purity water is concerned. There's no scum involved with our products. It will not leave calcium deposits in your working equipment. It's compatible with all coatings, and it prevents blast rust up to 72 hours or longer. And it applies to regular equipment like I was talking about. Again, pennies on the square foot, and it eliminates the high cost of brush blasting. You've all done brush blasting before to bring back to life what you've lost overnight with high humidity conditions, and think about how much time and material it costs to re-blast it. Well, if you use the whole blast the night before, you don't have to worry about that, unless, of course, there's a hard rain. No rewashing prior to coatings, and it's easy to handle, and it's extremely environmental friendly. Here's 72 hours after application with a whole blast, and up to 120 hours after whole blast. Now, I was offshore in a drilling rig. It lasted 9 days before we could start seeing flash rust taking place. We do offer technical support, and if you need a copy of any of this stuff that we're talking about, we'd be more than happy to forward it to you. Just get in touch with us. The NACE standard 0716 that we talked about, it talks about soluble salt testing, where and when and how much to test. SSPC Guide 15, it outlines the various methods used to perform field testing for salts. And the NACE 6186 has general information on soluble salts and discusses removal methods. We always have specifiers ready for testing soluble salts, and NACE is working with us in dealing with soluble salts, and chloride is always there to help you with technical questions. And it's always less costly to test and to do it right than to do it again. Now, we talked about all these things, and the final thing is ensuring success is that always test in the same spots where you found the problems, and you'll be fine. Soluble salts are non-visible highlights. Soluble salts do cause premature corrosion, and soluble salt remover requires an acidic product, not alkaline. And a flash rust deterrent requires a slightly alkaline product. Thank you for all of us at Chloride International. And if we can help with anything, just please give us a call or visit us on our website. Josiah, I'll turn it back to you.
All right. Hey, thanks so much, Norm. Now we're going to do the Q&A portion for today's webinar. If you'd like to ask a question, please use the question chat box that should be originally set up on the right-hand side of your screen when you opened up today's webinar. You can ask us questions there. Time and content restraints may keep us from asking all questions, but the questions can be sent over to the presenter afterwards, and he can answer them in an email afterwards. So let's get the ball rolling here. This is a question that was asked about 20 minutes ago. What is the concrete chloride test used for? Wet concrete mix or cured concrete surfaces? And what are the reasons it's used? What are the reasons that it's used for?
Generally, it's if you're pulling out core samples of concrete, you can get down in there and test for chloride salts that's inside. If you're having issues with rebar for the concrete, to see if it's inundated with salt contaminants, because if that rebar gets contaminated with salts, that rebar will probably increase in size about 10 times its original size and cause cracking and splitting of the concrete and evidently future failure. So you can get on our website and look at the Chlortest CSN, and all the information that you would need, including safety data sheets and all that, is in there for your view.
Okay. Why is an acidic compound necessary to remove soluble salts?
Well, that's what I was going over with all of the standards, ISO 8502 standards, and A6G 186, et cetera. And also with what I was talking about with the AAA solution, where alkaline, acidic, alkaline products is the only thing that can remove the salts out. Alkaline products will only cover over existing salts.
Is high pressure application?
Go ahead. I'm sorry.
No, go ahead.
Those formulations or these standards that I'm just talking about and reading about, if anybody needs that, they can get with us, and we'd be more than happy to send them a copy of it and they can read it for themselves. It's not Chlorid's opinion. It's just proven data that's documented from all of these major sources over the years that prove that acidic solution is the only thing that works for salt removal.
Okay, is it required to use high pressure application, or could you use a weed sprayer type applicator?
In extremely selective cases, we've used the bug sprayer type, but we do not recommend that. Maybe just for a small little job where you flush it as much as possible. But we do recommend 3,000 psi for chlorid and 1,500 psi for whole blast in order to get it to push the chlorid solution into the micropores of the steel to be able to dissolve and flush away those contaminants. Bug sprayers, just spraying it on there, cannot make it force it down into the micropores of the substrate successfully enough.
Okay. Do you have any thoughts about osmotic blistering in an immersed surface?
An immersed surface?
Yeah.
Yes, sir. Osmotic blistering will happen basically below the waterline as well as in all atmospheric surfaces. But I have seen over the years where we've had some issues with osmotic blistering on the bottom hulls of ships and fuel supply boats and things of that nature, to where there might be a pinhole or actually some soluble salts that's on the substrate that wasn't detected and coated over. And like I was saying, these coatings are all hydroscopic, that it'll pull that moisture in. And when it finds that salt, it starts feeding off of it, and the result is going to be a lot of osmotic blistering. There are some cases where some of the blistering may look to be osmotic, but it's usually in a spiral looking format, to where it's been more or less contaminated with electricity on a dry docking base or something, and they had a poor electrical charge that caused that type of blistering. But that's very, very rare. If you're seeing osmotic blistering on the bottom of a substrate of a ship or what have you, generally it is a chloride salt that's causing that, and it's easy to take care of.
Okay, here's a question that came in here. This attendee was curious, what specifically does the term hygroscopic mean?
That hydroscopic means that the salts attract water. You know, they're feeding off the water, and when you have salts up underneath the coating, and they're there when that moisture goes in and out of that coating, and the salts cling to that moisture. Once it does that, then it starts thriving off of it. It's in a feeding frenzy, and it'll just, that solid that water will just keep on feeding during the condensation process, and they just keep on feeding that salt, and that's why you see heavily pitted corrosion up underneath the coating system. When you see in that is every time moisture goes penetrates through that coating system, it's feeding into that um, um, that corrosion cell, and it's just getting larger and larger and larger until you have no more steel. It'll actually eat a hole into the substrate.
What are acceptable levels of salt on masonry for mineral paints?
There's a question I can't answer you. For the attendee, Josiah is going to send us the information to Chlorid corporate office, and if you would just politely leave your contact information, we'll gather that information, and I'll have to get that to somebody that deals with masonry more than I do, and we do have the experts to be able to take care of that for you.
Okay. Um, we've gotten caught up on the questions that I had queued up here, so let me take a look here at some of the ones that just came through. All right, do residual soluble salt contaminants contribute to corrosion?
Absolutely.
Okay, let's see here. What else?
Oh, go ahead. Coated over, Josiah. If it's coated over in any, you know, whether it's residual or what have you, knock it out of the way, and it lands on a surface, even though it's not electrochemically attached at this time. If it's not blown away or removed and it's coated over, eventually that salt is going to work its way down into the substrate, and it'll be there attached, like I said, electrochemically, and it's going to be there, and it's going to feed off of that moisture, and it's going to cause corrosion. You need to remove the salts, period. And we do see 2 and 3 times longer the life of a coating system when it's clean and when the chloride, sulfates, and nitrates have been removed successfully.
All right, here's another application and tool question it's similar to the one I asked a couple minutes ago. Is it possible to use airless pump to wash the surface?
I've done it a lot of times in the past, but you do need to have at least a minimum bulldog pump that will give you, it's a 30-to-1 pump, and it'll give you 3,000 psi at the tip, as long as you have a good tip that's in working order. And you need to make certain that the pump and the fluid hose is cleaned out to where there's no solvents involved. If there's solvents in there, you could have some other problems, but you just need to make certain that the lines are very clean.
All right, fantastic. All right, well, that is going to wrap up our Q&A session for today. I would still encourage everybody, while this webinar is still going on, to send questions over to us, and they'll be sent over to Norm after all our information on this webinar has been compiled. But before we wrap up today, a couple more things I just want to point out to everyone. Today's presentation has been recorded, and we will make it available for everyone to view probably around 5 p.m. Eastern time today. I would expect to see it around then. If you go to painsquare.com/webinars, click on the title of today's webinar, and from there you'll see an embedded video of today's presentation. At that same spot, you will also be able to see slides from today's webinar in a PDF format. All you got to do, again, just go to painsquare.com/webinars, click on the title of today's webinar, and you'll see the slides and the video right in there. If you're not already signed up for the Paint Square News daily e-newsletter, we encourage you to do so. You can find information on news, features, coatings forums, and of course webinars. All you have to do is go to www.paintsquare.com/PSN. Now finally, I'd like to thank Norm and of course our sponsors today, Chlorid, and also of course to our attendees today who sent in some great questions. And today is our final webinar of the year. So I just want to use this opportunity to wish everyone a happy holiday season and a safe new year. And we look forward to presenting more webinars for you guys in 2018. Take care. Have a great day. Have a great rest of the year. Have a good one, guys. Thank you.
Thank you, Josiah. Merry Christmas.